Okay, so it's about time we started to tackle some of the systems which the controls will drive. As this is a game rig, we want the base skeleton to be left as clean as possible. So what we're going to do is create a series of control joints. What these are copies of parts of the skeleton which the main controls will be connected to. These will then drive the main skinned skeleton. This makes for a cleaner rig, especially when it comes to exporting. It can also give you the option to quickly detach the rig if needed. Really quick question for you now. How would you like to help support the future of this channel and keep these videos free? Well, there are a few options. One would be to simply treat me to a coffee at my coffee page as a quick and easy thank you. You could also grab something from the antCGi store or one of my other online stores like CubeBrush and Gumroad. This is where you will also find the course files that go with this course, so you can download them and follow along. However, for as little as 99p a month, you could join the antCGi club. There are a few ways you can join. You could head over to my Patreon or Coffee pages, or alternatively simply hit that join button below this video. In short, the more support I get, the more time I can dedicate to creating more high quality content just for you. To get more information on how you can help, follow the link on the screen or in the description below. Okay, now that's out of the way, let's get on with the video. So first we need a copy of each section of the skeleton. Let's hide the controls for now. And then select and duplicate the root joint. You can press Ctrl and D to do this. Move it out of the hierarchy so we can work on it. Now unparent the legs. And the arms. And the pelvis. We don't need the root or cog joints, so delete those. You can also delete the head and eye joints, and the clavicle joints. Now let's hide the main skeleton. Let's quickly remove these from the bind joint selection set. They are in here because these are duplicates of the main skeleton. We can just right click on the selection set and go to Sets, Remove from Selection Set, and then select Bind Joints. That's better. We don't want those accidentally being selected and skinned. Okay, now we need to simplify the limbs. We don't need the finger joints, so delete those. And also remove the twist joints. Let's update the other arm. With the legs, we are going to keep the toe joints for now. This is so we can blend between IK and FK with them, something we don't need to do with the fingers. Not on this rig anyway. We do need to remove the twist joints though. So there we have the main areas of the skeleton. Let's change the colour of them because they still have the colour coding from when they were originally skinned. We can do this with the wireframe colour tool. Select the root joint of each hierarchy and go to Display, Wireframe Colour. If we click Default, you see the joint colours have now been removed and they are back to the default colour. We could, however, give them a new colour. Purple maybe. Okay, that looks good. You can also change this drop-down box from Index to RGB, so you can specify a custom colour instead. This is exactly the same as if you were dictating a colour for a control. Now we need to rename these joints. Firstly, so there are no name clashes in this rig, but also so we know what these joints are used for. Let's update the right side first. So select the right arm and leg, and go to Modify, Search and Replace Names. We can use this tool to quickly search through the hierarchy and replace part of each name. So we could search for _r and simply replace that with _r_ik, essentially tagging these as the ik joints. Because we had it set to hierarchy, all the child joints are updated now too. Let's update the left side now. So search for _l and replace with _l_ik. That's done. With the spine, we will just go through and rename manually because we have nothing we can use to replace at the end of each name. So those are the ik joints. Select them and duplicate them so we can create the fk joints. These now have ik1 on the end, so let's rename that first. So replace _ik1 with _fk. And now we can update the child joints. Okay, let's group these temporarily so we can clean up the outliner. So there we have our FK group and an IK group. Okay, let's look at the arms first. So bring back the arm controls. And move these skeletons apart for now. Let's change the colour of the FK arms so they look different. Maybe yellow. Actually blue. Okay, that will do for now. So we need the skinned skeleton back now. What we are going to do first is make sure the arm's control joints follow the arm root joint. This means the animator can use the control to reposition the arm if needed. And this will eventually also drive the clavicle too. First, we need to clean this control so all the translate and rotate values are set to 0. We can do this quickly as we did before by simply moving these attributes down to the transform offset parent matrix attributes. Now I'm going to cheat and use a small script I created to do this for me, and these will be available as part of the course. I will actually probably package them up in a nice UI for you too, so you don't need to access them on the shelf. So I just click this, and there we go, the attributes are moved. So we don't need to use an offset group here, which is good. So now we do need a group. Press Ctrl and G to create an empty group, and rename it to arm_group. It's good practice to give each element a recognizable name. Like here I've used _grp. This just means later in the rigging process, if I want to quickly select and lock all the groups, I can just search for _grp. Like previously when we were using offset groups, I could just then search for _offset and quickly lock them all at once. At the moment, the arm group is down here, so we need to reposition it so it matches the arm root control. Add the control to the selection and go to Modify, Match Transformations, Match All Transforms. That's now jumped up here. Again, we are going to clean up those transforms using the offset parent matrix attributes. What we now need is for the new group to follow the root control. We could simply parent the group to it, but I prefer to keep my systems separate where possible. So we don't want joints nestled under controls. Open the node editor and bring in the root control. And let's remove those shape nodes. We should add an L into the name so we know that this is for the left arm, and bring that into the node editor too. Open these. Usually we would use a constraint to make the group follow the control, but we can do something much simpler and more effective. All you need to do is take the world matrix 0 attribute from the ARM root control and connect it to the ARM group's offsetParentMatrix attribute. We can now move the control and the group follows. Let's move the ARM control joints under the new group. So you see, we can now position the whole arm. What we need now is for the skinned arm to follow the control arms. We also want to be able to blend between the two, so the animator can work in either forward or inverse kinematics. Now with this being a game rig, we can't use the matrix attributes or nodes. Not currently anyway, but I hear that there may be a solution for this coming up in a future release. Let me explain why. So here we have two joints, and each is being controlled by a NURBS circle. The first is connected using a constraint. The second is connected using the offsetParentMatrix attribute, just like we did with our root control. Let me show you. So here we have the connection, just the same as we did with the ARM root control. Here we have the constraint. Just remove these and open these. So you can see how much more complicated constraints can be. But just because we have the matrix nodes, it doesn't make the constraints redundant. We still need them in our lives. Okay, these have some simple animation on them. Animation which needs to be baked and sent to Unreal Engine. So the animator has animated the scene. All we need to do is select the joints and go to Edit, Keys, Bake Simulation to bake the animation onto the joints, all ready for export. Now that's baked the animation onto the joints. If we scrub the time slider, everything seems fine. We have all the keys here. Let's delete the controls, and let's try that again. So now you see that only the joint which was connected with a constraint has retained the animation. This is because the constraint passes translation values to the main attributes, which are then baked. With the offsetParentMatrix connection, no values actually appear here, so nothing is there to be baked. So with our rig, you need the control joints to drive the skin joints using constraints, so we can retain the animation information. Although you can use other nodes like the blend colors nodes if you prefer. This will simply blend between two sets of attributes, and there are videos available online which showcase this option. Okay, back to our rig. Select the upper arm control joints, and then the skinned joint. We don't want the twist joints at this point, so select the main joints for now. Now go to Constraint Parent. Disable Maintain Offset because we want the skinned arm to move to the other positions. And apply that. Now do the same with the lower arm. And finally the hand. Here we have those constraints. And you can see the weights in the channel box. So the hand will blend between the IK and FK hand joints. They currently both have a value of 1, which is why the hand is floating between them. If I reduce the FK weight to 0, the hand joint now moves over the IK joint. If I do the opposite, the hand now moves over the FK arm. So we can use these values to let the animator blend between IK and FK. Let's open the node editor and select the left arm control. So this is where the IK-FK switch attribute comes into play. Let's bring that into the node editor and open it. You can press 3 to quickly open a node. There we have the attribute. We now need the 3 constraints, so select those and bring them into the node editor. We don't need to open these. Now connect the IK-FK switch attribute to each constraint's FK weight attribute. Hand FK, lower arm FK, and upper arm FK. The arm has now snapped to the IK arm because the IK-FK switch attribute is set to 0. If we set it to 1, the arm goes back to floating between the 2 control arms. This is because the IK weights are still set to 1, no matter what we set the FK weights to. So we need to update those too. What we need is for the IK weights to be the opposite of the FK ones. So when FK is set to 1, IK is 0 and vice versa. We can achieve this with another node. Press Tab and start to type reverse. Create a reverse node. This will take a value and reverse it, so we can use it to invert the IK-FK switch value. Rename this to ARM IK-FK reverse. Now the node editor and its many nodes can be quite intimidating, so I would recommend checking out my video on the node editor over on my channel, where I offer an explanation on how it works. Essentially, we have 3 input attributes here, and also 3 output attributes. We just need one for now. So connect IK-FK switch to input X. And then output X to each IK weight attribute on the constraint nodes. The arm has now snapped to the IK control arm. We can now use the IK-FK switch attribute to blend between the 2. What's more, we can also use the proxy attributes we added to also control the blending. While we have these nodes here, let's make them work a little harder. Remove the constraints from the editor, and now bring in the IK and FK text. What we can do is use the same attributes to also show and hide these. Connect the IK-FK switch attribute to the FK text's visibility attributes. Do this for both the F and the K. And now the output X attribute from the reverse node to the IK icon's visibility attributes, so the I and the K. Now as we switch, the text changes, so the animator gets a visual representation of what state that limb is currently in. It's a small thing, but it can help when it comes to animation, and in particular navigating the rig and the scene. So, we now have the control joints set up for the left arm. We can pose the FK arm, and the skinned model will happily blend to it from the IK arm. All we need to do now is move the control arms back into position. So, select the root of each, and then the root control, and use the Match Transformations tool to move them back into position. The whole arm now moves with the root control, and we can blend between the 2. Now we aren't going to go further with this arm rig at this stage. For now we are just setting up all the control joints so the main skeleton will move with them. Now we are done with the arm, let's move it into the rig systems group. So for the right arm, it's exactly the same process. So I'm not going to go over all that again. Instead, let's have a quick look at the legs. And again, this is pretty much the same too. So first, clean up the transforms on the root control, just moving the values down to the Transform Offset Parent Matrix tab, or use the script if you have it. That's done. Now create an empty group and call it Leg Left Group. And reposition that so it matches the root control. Also, clean up the attributes too. Those values are down here now. Now open the node editor. Actually, before I clear this, because it has 3 inputs, you can use the same reverse node for the right arm. Simply use the input Y and output Y attributes instead. There's no point adding another node when you can share them. Okay, now that's out of the way, let's clear this. And bring the leg root control and the leg group in. And open these. Just as we did with the arm, connect world space 0 to offset parent matrix. So the group now moves with the control. We now need to parent constrain the skinned skeleton to the control joints. Remember to disable maintain offset. Now the knee, and the calf, and now the foot. We also need to connect the toe joints too, so go through and constrain those. A quick way to work through these is to press G to repeat the parent constraint, and then simply pick walk down the hierarchy, and press G again. So we have lots of constraints now. Let's organize this a little better. And bring in the main leg control. Now connect the IK/FK switch attribute to each constraint's FK weight attribute. Okay, that's done. Now we need another reverse node, so press Tab and create one. Oops, just bring those back in. Okay. Call this leg IK/FK reverse. Again, we can use this for both the left and right legs. Bring the control back. So IK/FK switch goes into input X, and output X goes into each constraint node's IK weight attribute. We can now blend between the two control legs. Okay, let's update the text now so it represents which leg is being used. Remove the constraint nodes and bring in the text curves. Now connect IK/FK switch to the visibility attributes on the FK text curves, and the output X attribute from the reverse node to the IK text visibility attributes. Okay, great, that works. All we need to do now is move the leg control groups into the leg left group. and snap them back into position so they all lie in the same space. OK, done. Let's move the main group now into the rig systems group. OK, that's the control joints set up for the left arm and leg, and we can blend between IK and FK. As mentioned earlier, the process is exactly the same for the opposite leg and arm. You can also apply the same technique to the spine too. With this, instead of using the root control, you can use the cog control as the main position control for the spine. OK, I'm going to update all those now, and I will be back in a few seconds. Right, that was quick. So here we have all the control limbs and the spine set up. If I just move the IK joints back, you see he follows. We can use the IK-FK switch attributes to blend back to FK2 when needed. You can see the spine follows the cog control, just like the limbs follow their root controls. I also updated the cog control so it has the same attributes as the main IK controls too, because we will need these options for the spine. We can also blend between IK and FK with the spine. OK, so that's the control joints set up and ready for the main controls. So in the next video, let's start building the main systems. OK, that's another video over. Thanks for watching right to the end, and make sure you also check out some of the other free videos and courses that I have available. You can find links to all these on the screen now and in the description below. Remember, to help support future content and keep these videos free, visit the antCGi store or join the antCGi club. Alternatively, if you would just like to show your appreciation for these videos, why not treat me to a coffee at my coffee page? Again, the link is on the screen now and in the description below. Thanks again for watching. This is antCGi signing off, and I will see you on the next one.